So just like we could multiply square roots together, we could break square roots apart. We could put them in like a prime factorization, like you might have done a couple of years ago in sixth grade when you made your prime factor trees. And that's very similar to what we're going to be doing right now in exercise number 4. So we're going to split them into factors, and we're going to put it into this form known as simplest radical form. And again, it uses part A as a guide. So if you want to take a look at part A, you could pause the video and take a look at part A. And we're going to go ahead and start with part B. Okay, ready? So what I want to do is I want to go to this thing called the radical party. Now, when you go to the radical party, you have this whole big radical. And if you didn't know, another name for the square root is the radical. So now, before we can go to the radical party, we need to make a prime factor tree. So remember, prime factors are numbers that are only divisible by 1 and itself. So let's just find out any two numbers that multiply to 288. I see that it's an even number, so I'm going to start off with 2. If it's prime, I'm going to circle it. If it's not, I'll keep going. 2 times 144 will give me 288. Now, 144 is not prime, so I could simplify that further to the square root of 2 times the square root of 72. 2 is prime, so I'll circle it. 72 is not, so I'll keep going. Now, I might see that this is 8 times 9. And again, you might keep going with 2 and 36, and that's fine. There's multiple ways to do this. So now, I'm going to break this one down to 2 times 4. The square root of 2 times the square root of 4. 2 is prime. And the square root of 4 will give me square root of 2 times the square root of 2. Square root of 9 can be simplified to square root of 3, and 3 is prime, and the square root of 3. 3 is also prime. Now it's time for that thing that I said in the beginning of this problem, is the radical party. So for the radical party, you want to draw the big radical house. Now, in order to leave this radical house, you need to have a pair of the same number. So it's like Go Fish. When you get a pair, you take a pair and you put them outside of the game until at the end of the game when you count them up. So let's see if we have a pair of anything. Oh, we have a pair of 2's right here. So I'm going to cross off 2 2's, and I'll write 1 2 on the outside of the radical. Now, I look for any other pairs. Okay, I have another pair of 2's. Here's 1, here's 2. So when I get a second pair, I'm going to multiply it. Okay. And finally, I have a pair of 3's over here. So I'm going to put a 3 on the outside, and they're all connected by multiplication. Now I've got this single 2. So remember, the radical party, the only way you could leave the party is when you have a couple. So the single 2 has to stay inside all by himself or herself. Now I could simplify this up because 3 times 2 is 6. 6 times 2 will give me 12. So I'll get 12 radical 2, and always a plus or minus answer. So if you were to put in your calculators 12 times the square root of 2, you'll get some long, crazy decimal. But then if you tried to put in the square root of 288, you're going to get the same long, crazy decimal. So what we just did was we simplified this radical to something called simplest radical form.